Okay, so let's go ahead and get started. I show that it's 8:59, so nope, 9 o'clock now. Okay, so you do have a review for the final. It's 46 questions long, and I recognize that it is long, so that's why you want to get started working on it as long as possible. It is only worth 10 points in the grade book, though, but I think you need to do it to be prepared for the final, so get started on it. It's not due until tomorrow at 11:59. Your final exam has 30 questions, so it's just about doubled. And you get double the time. So 30 questions, you get 2 hours and 20 minutes, that's 140 minutes. And again, I think everybody got it scheduled. It's again due tomorrow at 11:59. Don't forget to send me the work on Friday morning. Then I will come in and grade them and get them put over into Blackboard. For those of you that did the M4 discussion, your peer replies, which are worth 2 points. If you don't do it, you get 8 out of 10, are also due. And tomorrow we'll do an office hour at 9 o'clock, so I'll be here again at 9. If you have any questions about the review for the final as you work through it, then you can definitely log on and ask some questions about it. So what I want to do today is I've actually printed off the review for the final, and there are specific questions I want to concentrate on. So these are definitely questions you will see on the final, but I'm not going to go over all 30 of them because we just don't have time and you'll get overwhelmed by it. These are ones you definitely want to make sure you work through. So the actual first one I want to work through is number 1. So I'm going to number them like they're numbered on the review, and that should be consistent for everybody. So my number 1, and each person should have a different one, is to solve an equation involving a radical. So we want to solve the square root of, and this goes way back to day 1, 2 times the quantity x plus 15, and then minus 3 is equal to x. So the square root of 2 times the quantity x plus 15 minus 3 is equal to x. And we want to solve this for x. So on day 1, we talked about radicals, and the very first thing you need to do is make sure you get the radical by itself. So we're going to move this 3 to the other side. So that'll give me the square root of 2 times x plus 15 equals x plus 3. Now once you've isolated the radical, you can come in and square both sides. So that's going to give us 2 times x plus 15 is equal to x squared plus 6x plus 9. And again, remember on the right side, because there's a sign on the inside, you have to make sure you FOIL that out. We can distribute next. 2x plus 30 equals x squared plus 6x plus 9. Now that it's a quadratic, we're going to set it equal to 0. So we'll move everything to the same side. So it's x squared. When I move the 2x over, I'll subtract and get a 4x. When I bring the 30 over, I'll subtract and get a negative 21. And now we need factors of 21 that are going to subtract to 4. So it does factor nice and neatly. So x plus 7 and x minus 3 subtract to give me 4 and multiply to give me 21. So x equals a negative 7 and x equals 3. So you do need to check your solutions to make sure they work. I'm a little worried about the 3, but we'll plug them in and see. So when I plug in 3 plus 15 is 18, 2 times 18 is 36, square root of 36 is 6, and 6 minus 3 is 3. So that one definitely works. Plugging in the negative 7 plus 15 is 8. 8 times 2 is 16. Square root of 16 is 4. 4 minus 3 does not give me a negative 7. So that one doesn't work. So you get one that works and one that doesn't work. But that should be your first problem. So something similar to that. Questions or comments on those radicals? Because it has been a while.
I'm good.
No, I'm good. Good. Okay. Moving on then. Okay, on the review, question number 2 is a substitution question. Again, we're going to solve x to the negative 2 minus 5x to the negative 1 plus 4 is equal to 0. So x to the negative 2 minus 5x to the negative 1 plus 4 is equal to 0. And again, the clue that it's a substitution problem is that you have 3 terms and you have weird exponents, right? So those weird exponents say use a substitution. We're going to come in and let u equal x to the negative 1. So that first term becomes u squared minus 5u plus 4 is equal to 0. Which factors? U minus 4, U minus 1. So U equals 4 and U equals 1. But then you have to unsubstitute. So x to the negative 1 equals 4 and x to the negative 1 equals 1. So translating this means 1 over x and this means 1 over x. And then all we have to do is cross multiply and solve for x. So when I cross multiply, I'll get 1 times 1 equals 4 times x, or x is equal to 1/4. Over here, you're going to get x is equal to 1. So we get 2 answers, the 1/4 and the 1. So it's not hard through here. It's this unsubstituting that causes problems. So just remember the negative exponent means to move x to the denominator and then solve from there. So questions or comments about the substitution problem? Okay.
I'm okay.
Yay. Okay, then I'm going to skip up to question number 8 on the review. So number 8 says, for the given equation, we want to list the intercepts. And test for symmetry. Okay, and then the equation is y equals x cubed minus 125. So x cubed minus 125. Good morning, Matt. So what we're doing is actually working through the review for the final exam. We're going through some specific questions that will be on your final, just in a different format. So again, what it does is it generates a new question for each individual taking it. So, okay, how do I find intercepts? So how do I find the x-intercept?
Y equal to 0.
Yep, so we're going to see 0 equals x cubed minus 125. So 125 is equal to x to the 3rd. And then we'll cube root both sides. It works out nicely. We get x equals 5. So the x-intercept is 5, 0. The y-intercept is the easier one for this equation because we're going to let x be 0. We can see that y is a negative 125. Great. And now it's the testing for symmetry. And again, this is all the way back in chapter 2, so it's a ways to go, right? Okay, so for the x-axis, if you remember, what we do is replace the opposite variable. So that would be negative y equals x to the 3rd minus 25. And I'm going to compare that to the original equation. And we can see that it's been changed. It is not the same. So that means it does have no symmetry. So no symmetry to the x-axis. In other words, I can't fold it across the x-axis and have it fold onto itself. The y-axis, you do the same thing, replace the opposite variable. So that would be y equals a negative x cubed minus 125. Well, a negative number cubed is negative. So, and then I'm going to compare that to the original. And again, I can see that the sign on the x is changed. So it has no symmetry. Okay, so the only thing left to check is the origin. And it looks like I've run out of room, so I'm going to go erase. So here we're going to replace both the x and the y. So I end up with negative y equals a negative x cubed minus 125. And I'm always suspicious when I have negatives on both sides that I could divide them out and get back to my original. So I'm going to divide everything by negative 1. That'll give me y equals x cubed plus 125. And I'm closer to the original. The y and the x are the same, but the 125 has changed. So this particular problem has no symmetry. If we went to graph this, we could see that it would not fold over anything. Okay, so that's the way ideally you should work the problem, but recognize that this is a cubic function that's been shifted down 125 units, right? So our cubic function shifted down to 125 would do this. So we can see from the picture of the graph that it has no symmetry. So that's another way to think about it in terms of finding symmetry. So. Okay, any comments or questions about that? So you'll have one of those. Okay, number 9 on your review. And again, what I'm doing is hitting the ones that I think you'll struggle with just because they've been so long or they were harder concepts. So that's why I went through and picked out the ones that I did. Number 9 is asking us for the equation x squared plus y squared minus 4x minus 2y minus 11 equal to 0. We want to do the following. We want to find the center and the radius, graph it, and find the intercepts. So we need the center, the radius, and graph. And unfortunately, I cannot take off the part about finding the intercepts, so I'm just going to ignore that. When I go through and grade it, you'll automatically get full credit for finding the intercepts no matter what you find, because we didn't really concentrate on it. So let's go find the center. If you remember what we need to do, whoops, is to complete the square. So I'm going to group the x terms together. Then I'm going to group the y terms together. And I'm going to move that 11 to the other side and make it positive. So I've separated my variables is what we're doing. Okay, now we'll come in and do the actual completing of the square. If you remember what we did is we took half of 4 is 2, you're going to square it and then add it to both sides. So if I add 4 on the left side, I have to add 4 on the right side. Do the same thing with the 2, half of -2 is -1, but a -1 squared is a +1, so I'm going to add that to both sides. So on the right side, I end up with 16, which is wonderful because that's a perfect square. On the left side, I need to factor x squared minus 4x plus 4. Well, that factors into x minus 2 times x minus 2. 2. Y squared minus 2y plus 1 factors into y minus 1 and y minus 1. So when we're done with our algebra, we have x minus 2 quantity squared plus y minus 1 quantity squared is equal to 16. Okay, and the formula for the circle was x minus h quantity squared plus y minus k quantity squared is equal to r squared. So our center is at 2, 1, and our radius is at 4. So, and remember, as you pull things out of parentheses, you switch their signs. So then you can graph it. I mean, you guys don't need my help graphing at this point. So 1, 2, up 1, and then you're out 4. 4, 1, 4. Okay, so obviously it has both x and y intercepts, and you can type anything you want in for those. It's going to mark them wrong, but I'm going to come back and give you full credit on them. So I would not waste the time finding the intercepts because I'm not going to grade that part. Comments or questions about your circle? No. Wow. I don't know what number the next one is because it printed the number on one page and then went in and did the problem on the next page. It drove me crazy when I was printing it out. So yeah, let's see if I can figure it out from the following problem. Nope. So somewhere between 18. Yeah, and then I got rid of those pages because I thought I didn't need them. That was bad. Oh, so it's going to be problem number 16. I can figure it out. Okay, so this is 16. I really like this problem, but it is a long problem again. So it says, answer the questions about the following function. So f of x equals 4x squared minus x minus 3. So 4x squared minus x minus 3. First of all, they want to know, is the point -2, 15 on the graph. So that's the first question. So they just want you to plug in -2 and see what you get. So -2 squared is a +4 times 4 is 16. And then minus a -2 gives me +2 minus 3. So that's 16 plus 2 is 18 minus 3, sure enough, is 15. So the answer is yes, that point is on the graph. So that's a simple plug and chug. Part B says, if x equals 2, what is f of x? And I'm not worried about that part because you guys can plug numbers in. So I'm going to leave that part alone. You guys can do that. Part C says, if f of x equals -3, what is x? So this is the part I'm worried about. So in other words, what they're saying is that the output is a -3. What is the input? So I'm going to set the function equal to that y value of -3, and then we need to go solve it. So don't freak out when I move that 3 to one side and it cancels out. I then have 4x squared minus x, and then all you have to do is pull out an x. So x equals 0 and 4x minus 1 equals 0, so x equals 1/4. So the two values would be 0 and 1/4. So they're giving me the y value, asking me for the x value. That's the only part I was really worried about. Part D asks for the domain. Well, we take a look at our function. A couple of things are going on in your brain. You know that that's a parabola, and we know the domain of any parabola that we graphed would be all real numbers. So no work required. They asked for the x and y intercepts. You know how to find those. You'd set it equal to 0 to find the x-intercepts and plug in an x of 0 to get the y-intercepts. So you can do the other parts to it. But it's got 6 parts to it, so it's a long problem. Okay, any questions on that? That's from chapter 3.
I'm good.
Okay, moving on. This is number 19. They want us to find the average rate of change. Of f of x equals 3x squared plus 1. And we're going to go from 1 to 3. So part A is from 1 to 3. So, well, what are we going to do? Well, in order to find the average rate of change, it's the slope of the secant line. So we know that this is a parabola. We know it's doing something like this. And what they're asking us to do is to go between 2 points and find the slope of that line. And that's what the average rate of change is. Well, I need the coordinates of the points. So the very first thing we have to do is find f of 1. So that would be 3 times 1 squared plus 1. Sorry, that's really sloppy. 1 squared is 1 times 3 is 3. 3 plus 1 gives me 4. And then I also have to evaluate the function at 3. So that would be 3 times 3 squared plus 1. 3 squared is 9 times 3 is 27 plus 1 is 28. Okay. So in other words, I have the point 1, 4, and I have the point 3, 28. So to get the average rate of change, we'll do our slope. That's the change in y over the change in x. So the change in y would be 28 minus 4 all over 3 minus 1, the change in x. So 28 minus 4 is 24, 3 minus 1 is 2, we end up with 12. So the slope of that line would be 12, so fairly steep. So, okay, and that's average rate of change. That was somewhere also in chapter 3 floating around. Any comments or thoughts about that?
No, I'm good.
Okay. Yay! Okay, moving on. The next one I want to look at, oh, here we go with another one with no problem number on it again. That's just wonderful. It's a good thing it prints out page numbers. I'll get there, sorry. 27. Looks like this is number 26. So skipping up to 26. This the given quadratic function f of x equals negative x squared plus 6x. Answers parts A through C. So part A is determine whether it opens up or down. So does this open up or down? We know it's a parabola
Down.
because of the x squared, so it's down because that lead term is negative. So that's what's telling me down. They then want me to find the vertex, and this is the only part that I was really worried about. How do we find the vertex? Do you remember? We got a formula.
Negative b over 2a.
Beautiful. Yep, negative b over 2a. So it's a negative 6 over 2 times negative 1. That's a negative divided by negative is a positive, and 6 divided by 2 is 3. And then what do I do with that? We're going to plug it back into the function.
Yeah.
So what that is the x coordinate of the vertex. So to get the y coordinate, we'll plug it back in. So a negative of 3 squared plus 6 times 3. Be very careful. Square first. That's a 9. Then make it negative. 6 times 3 is 18. That's going to give me 9. So we know the vertex is at the point 3, 9. Okay, they then also ask for the x-intercepts and y-intercepts, and they're going to have you graph it also. But I wanted to make sure you remembered how to find the vertex. So, yeah, x-intercepts, y-intercepts, and then the domain and the range. You're going to pull the domain and the range off the picture once you've got it done. So, any problem finding the vertex? No. Moving along pretty good then. Okay, I'm going to skip to number 30. So number 30 says, analyze the graph of r of x is equal to x squared all over x squared plus x minus 90. Yep. X squared plus x minus 90. So the very first thing they want is the domain. So to get the domain, we're going to take that denominator and set it equal to 0 because we cannot divide by 0. Luckily, it factors into x plus 10 and x minus 9. So we see that x equals a negative 10 and x equals 9. Now, these are the vertical asymptotes, but they're places where the domain has issues. So we know that x cannot equal a negative 10 and x cannot equal 9. And that's how they're writing the domain, right? So there's our domain. Part B says the vertical asymptotes. Well, we just found those. That would be x equal negative 10 and x equals 9. Part C says, what's the equation of the horizontal or oblique asymptote? So I would not give you an oblique because it was not on a previous test, so you know it's horizontal. And this comes back to the degrees. So in this case, the degrees are equal. So it's the ratio of those leading coefficients. And for us, that gives me a 1 in the numerator on the x squared and a 1 in the denominator on the x squared. So it would be y equal 1 over 1, which is equal to 1. And then once you've got that, part D of the problem is a matching. They're going to give you different pictures of the graph and ask you to match it. So what I fully expect you'll probably do is graph it on your calculator and then match the picture on the calculator to the picture on the screen. So they don't ask for the intercepts, which I thought was interesting, but oh no, it's on the second page. No, it's not. Nope, they don't ask for the intercept. So, okay, comments or questions about that?
Okay.
Okay, moving on. Okay, number 32 says to find the complex zeros. So now we moved up to chapter 5 of f of x equals x to the third minus 8x squared plus 25x minus 26. So x cubed minus 8x squared plus 25x minus 26. Okay, so does anybody remember how you have to start this problem?
All of P over all of Q.
Yep, all of P over all of Q. So you're looking for factors of 26 over 1. So that would be a 1, a 2, a 13, and a 26 all over 1. Okay, what's your next step? So in
Graph.
other words, yeah, we're going to graph it. That's exactly what I'm doing. So I'm graphing it right now because I didn't get that done. Plus 25x minus 26. That's not good. Okay, and graph. And so from the graph, on our calculator, we're going to come in and try positive 2. We're going to try 2. Okay. So that means we're going to try that in our synthetic division. So I've got my 2, my -1, -8, 25, and -26. We'll bring down the 1. 2 times 1 is 2. Adding is -4. 2 times -4 is -8. Adding is what? I get 17. Okay, where did I mess up? Oh,
It's 6. Yeah.
yeah, I just caught it. It's like, I can do that. Okay, -6. 2 times -6 is a -12. That's going to give me my 13. 2 times 13 is 26 and gives me a 0. So I knew I was on the wrong track because I wasn't going to get the 0 over here. And the calculator guarantees me that's a 0. Okay, now what's left down here is your quadratic. So that's x squared minus 6x plus 13 to 0. And then you'll go to the quadratic formula, one of the few places you need the quadratic formula. So 6 plus or minus the square root of 36 minus 4 times 1 times 13 all over 2. So that's 6 plus or minus 4 times 13, that'd be 40, that'd be 52. So 36 minus 52 over 2. So that's going to give me 16. Is that right? Yep, -16 on the inside, which works out really nice because I can take the square root of that. So the square root is going to give me 6 plus or minus 4i divided by 2, and then I'll divide everything by 2. So I end up with 3 plus or minus I. Woof. Okay, so then to answer the question, our zeros are the 2 that we used in the synthetic division, and then 3 plus I, and 3 minus I. So this problem is one of the main reasons you're required to have the graphing calculator for the course. So, okay, any problem with number 32? Okay, so apparently that was all of the ones that I thought that you might struggle with. So especially once you got into the chapter 6 material, I didn't circle any of those because you just did those on the exam. There was one going through everybody's work on the exam that I did want to talk about. Did I pick it up on the final? No, apparently I didn't put it on the final, so never mind. Scratch that thought. Okay, the only other thing I want to talk about is the application problems, just to remind you that we did do application problems, and I just want to tell you what kind of problems to expect. So as you're working through the review, pay attention to those. Okay. So you have a total of 5 application problems. Okay. So one of them is from section 1.7, which was a mixture problem. Remember, you're mixing peanuts and cashews or cashews and almonds, that kind of thing. So you'll have one similar to that. You'll have one that's from section 2.5, which is on variations, either a direct or an inverse variation problem. You then have one from section 3.6 where you're writing a function. So in other words, a right triangle is sitting inside of a curve. Find the area of the right triangle as a function. So it's a pretty straightforward problem. You'll have one from section 4.3, which is the farmer and the fencing. Farmer with fence. That's where you need to be able to find the vertex and the maximum or the minimum. And then finally one from section 6.8 that you just saw yesterday on exponential growth. So those 5 application problems. So again, the final's got 30 questions. And you get 2 hours and 20 minutes to take it. So I don't think you'll need the entire time, but you can judge it. If you've been using almost the whole hour to do the current exams, then you'll probably need a good 2 hours to do this one. So, okay, do you have any questions for me?
I'm good.
So again, I will be here tomorrow at 9 o'clock to do office hours again. So after you've started going through the review in Pearson, if you have any questions, just bring those to tomorrow to class and I can answer them. So anything else?
No.
I did get the exams graded and have moved those grades into Blackboard, so you can look at Blackboard and see your current grade. That's about all I got. Very good.
We're good.
Okay. Have a great day. Enjoy it. And Rich, I'll be sending you a text here in just a few minutes, okay?
Okay, thank you.
Bye-bye, guys.
Bye.